Okay, today, as a kind of a culminating example of all this electric circuitry and schematic stuff, I want to take a look at what I consider to be one of the, I guess, most important applications of all of this that I think people should understand. And that is how your house works. Because when you go to your house, you have a bunch of electrical devices. You can plug them in a variety of places. So how is what we have talked about kind of put together to explain how your house actually functions? So we're going to begin by taking kind of a conceptual look at how your electricity gets delivered to your house, and kind of a conceptual breakdown of what happens, and then we're going to come back and take that picture conceptually, and we're going to try and recreate it a little more from a schematic perspective. Okay? Now, I'm not going to go into your overall house, too much detail there. Here's your house, and when it comes to the electricity that gets delivered to your house, all of the electricity only comes in at one place. Now, whether or not you can actually see where the electricity comes into your house depends on whether in your particular neighborhood they have utility poles or whether they did the utility wiring underground. I live in a neighborhood where we have utility poles, so it's much more visible. So I'm going to go ahead and draw the utility pole out here. And there are wires that go up and down the street. Some of them are for communication, but some of them are also for electricity. Now, if you have a house and you live in a neighborhood where the electricity is delivered above ground, at the corner of your house, you will usually have a very solid kind of connecting point. So coming from the utility pole, you will have a very thick wire, and actually it's a it's triple stranded, but it will be fed to what looks to be like an open tube, and then it feeds down into that corner of the house. And if this is the case for you, you will usually find that connecting point at the corner of the house. Now, somewhere associated with the corner of the house where the electricity comes in on the outside, you would also end up seeing somewhere there, and I'm going to put a little round dial here because it is round, you will find your meter. And this, at least at our house, it's on the outside. And that meter, some people with the newer version of it, they call it the smart meter. The idea is that all of the electricity flows through the smart meter, and then, and I'm gonna conceptually bring it over here. We're going to look at the inside of the house now. Here is your main line. It's going to go through the smart meter, which again I said is usually found on the outside of your house, and then it is going to feed into what is referred to as your breaker box. Now, your breaker box will be located inside your house, and in our house, it's in the garage. And I think for most older homes, that's where you'll find it. In some newer homes, you will find it inside the house, maybe inside a utility closet or something like that. Now, if you were to look inside the breaker box, what you would notice are what look to be a bunch of switches. And the thing that are in here are called circuit breakers. Now, the circuit breaker is like a safety device. You could call it a switch, but it's like an automatic switch that's always on unless you try and run too much electricity through it. And so that's why that is all located here in this breaker box where all of the electricity comes in. And I'm going to come back here and remind you that this here is coming in from the street. So you got all your electricity coming in through the street. It goes through the smart meter, so the smart meter can record how much electricity is going through the one wire that feeds the house, and then you go to the breaker box. Now, when you look inside the breaker box, what you will normally see is up near the top, you will see like a big circuit breaker. And this is usually referred to as the main. This is like the kill switch for your house. If you were to ever turn this off, everything in your house would go dead. Now, underneath the main, what you would notice is you would have a couple, you could call them like columns, of what also look like switches. And these are also circuit breakers. But those circuit breakers feed separate parts of the house. So, for example, one circuit breaker might, and this is where we get conceptual, might feed over to one area of the house, like a particular bedroom. And then another one would feed over to another area, which could be the living room. And you could have another one that goes to your kitchen area, and then two particular that are special, because usually there are two of them that are tied together. One of them usually goes to your oven, and then another two go to your dryer if you have an electric dryer. So the idea is that all of the electricity feeds through the main to the breaker box, and then from the breaker box it gets split into, I guess we could call them sub-circuits. Okay, now what this allows us to do is that if there is a problem in the bedroom, or maybe if we want to do some electrical work in the bedroom where we want to replace a switch or something like that, we can actually come to the circuit breaker that is responsible for that area of the house, and we can turn it off so that no electricity flows there, and then we can do our work, but the remaining sections of the house remain active. And that's why we have this type of kind of dispersion of the electricity coming through the main breaker box. Okay? So conceptually, this is how electricity gets delivered to your house. All right, now what we're going to do is we are going to take a look at this. And I do want to add one extra thing. How many of these you have does kind of depend on how big your house is. The bigger your house is, the more sub-circuits you have. So some houses might only have half a dozen of these circuit breakers, or half a dozen to 10, and others you could have, a dozen to 15 if you have lots of different areas. So now what we're going to do is we're going to try and take this conceptual design and we're going to present it to you more in terms of a specific electric schematic where we use symbols. Okay? So, I'm going to erase this, okay? And I've prepared a diagram, so hopefully I can put this together all right. So, we have a main line that comes into, oh no! Okay, shoot. Automatic. I got to move around more so that the lights stay on. So we have the main line coming from the street, and then we go through the smart meter, okay? And now we are going to go into the breaker box. Now the symbol for a circuit breaker is this particular symbol, okay? So you're going to be seeing some of those here. So I mentioned first at the top of the breaker box that you had your main switch that would cut everything. So inside the breaker box, and I'm gonna kind of try and organize this a little bit once I draw it all out. You have an initial circuit breaker that will kill everything. And once it goes through there, what happens is, and I'm not going to draw tons of these, I'm just going to draw 5. You have a splitting of that current into individual circuit breakers that are the sub-switches in your breaker box. So we have this action going on. Now, from here, these lines then go out to those different sub-circuits that we've talked about. So what I'm going to do here is I am going to box this in just so I can highlight that all of this, even though it looks pretty spread out, this is all happens within the breaker box. Now, let's say that this particular sub-circuit goes out to a bedroom. Now, once it goes out to a bedroom, in the bedroom, this thing will split into a variety of different like plugs and light bulbs and things like that. And each one of those things we can symbolize as a resistor. But the thing that is special about all of these resistors is that they are connected in parallel. Now, I'm only going to put 4 here, but I'm going to put the little ellipses dots here because the truth is that how many there are, it just depends on how many things you connect into it. Now, I'm going to bring this thing back to here, but this is where I'm going to be very factual about this, that when you have a wire that runs out to a room, and for that matter, all of these wires, these are actually 2 wires that are usually wrapped in the same insulator. So I'm going to draw the picture like this, and each one of these circuits, when we talk about the wire coming out from the breaker box, it actually has 2 wires together that once you get out to the sub-circuit area, and again, we're pretending this is like a bedroom or maybe 2, each one of these resistors is a plug or a light bulb. Now, as you plug more things in, that adds resistors to this. So here I want to point out that all of these, and I'm going to do this in blue here, this connection here, all of these are series because all of the electricity has to go through this one, and all of the electricity to get out there has to go through this one. So these are points where if you just flip a switch, it would kill anything that comes after it because remember, in a series connection, you only have one pathway. Now, if this went to another part of the house, this would then go out, and again, it would be this, it would look like a single wire, but it has multiple wires inside of it. And once it gets out to whatever part of the room, whatever part of the house this services, then this creates another little sub-circuit with all these resistors, and they are all in parallel as well. Okay, I'm going to put one more so that we're all the same here, and then we're going to bring this back here, but this is where we would return. And again, this, I guess what we could do is we could put little dots here to show that when you go, how many resistors do we have? It simply depends on how many light bulbs, how many plugs, because every time you plug something in, you add another resistor into this. So the thing that I want to point out here is that in the general area of the house, everything here is connected in parallel. Now remember, when things are in parallel, you have multiple pathways. So for example, if one of these is a light bulb and it burns out, that means everything else can still function, electrically speaking. So when a light bulb goes out, it doesn't mean your plugs go out. Or if something that's plugged into a plug goes out, it doesn't mean the light bulbs go out. So these guys here would have a similar thing that we've created with these two subcircuits. So I'm not going to go ahead and create those, but hopefully you get the idea that this is the general house, and all of this is right where the electricity comes into your house. Now, a couple details here, and I'm only sharing this with you because we went through this when we bought our house. When it comes to the electricity that comes into your house, because of how many more electrical devices we have in today's world, some older houses have a hard time supporting a lot of the newer electronics because we have so many of them. So we've talked about current and that you measure current in amps. When it comes to how much electricity can we have flow into our house without having it cause a problem, this little circuit breaker right here, depending on what you want set up, is usually either set for 100 amps or 200 amps. So most more modern houses are set up for 200 amps because they understand there's a lot more electrical devices in today's world, but some older houses were only set up for 100. So when we bought our house, we had a 100 amp service, and what we did was we had to pay the electrical company a little bit, so they would come in and they could juice ours up, so we have a 200 amp service for our house. But this circuit breaker, it is set so that if for some reason we demanded more than our 200 amps that this circuit breaker was set for, this circuit breaker would automatically click and open up, and it would shut down everything going inside the house. Okay, now 200 amps is an immense amount of electricity. So we would have to have a tremendous amount of things plugged in and like all turned on at the same time in order to even get close to that. But once we break after the main breaker and we go into the sub-circuit breakers, these guys also have amp limitations, but they are much lighter. So usually these guys are either 15 amps or 20 amps, because the idea is that each one of these circuit breakers is only responsible for a certain part of the house. So you would not want to have it set for a large number, because you would, if you had that much electricity going into that section of the house, you would really be in a lot of trouble. So this is how your house functions. Now, trying to connect this circuit breaker idea out here. If you plug too much stuff in, or for example, let's say this is your kitchen, and you have one of these is your microwave, and you got all your lights, and let's say for some reason you need to go run a vacuum because you had a spill. Vacuums tend to be pretty power-hungry devices, so they increase the amount of current that flows. And so you plug in the vacuum cleaner, and then you go to turn the vacuum cleaner on, and then your kitchen circuit, sometimes they'll use the term, it blows. It clicks and shuts down. That's because when you had all of those things in operating at the same time, it demanded too much electricity just through this one. So this circuit breaker clicks off, and then what you are able to do is you have to go out to where the circuit breaker box is, and then you have to toggle the switch back and forth once, and then it resets this so you can try again. So if your microwave was running and then you tried to run the vacuum cleaner and then things clicked off, If you go back and reset it, if you don't run the microwave and then you turn the vacuum cleaner on, you're probably going to be fine. It's just because you demanded too much at one moment that caused the circuit breaker to trip. Okay? So, conceptually, this is how your house functions. I may have more to say at another point because I'm getting to the end of my 20 minutes here about the smart meter. Because the smart meter can give you a little bit of information. If you go look at it, it flashes through little screens, and one of the screens that it tells you is how many kilowatts your house is rated at a given moment. And it basically pretends your house is just one big resistor, and it gives you an overall value. And sometimes that can be pretty interesting because if you look at it in the morning and then in the afternoon and then in the evening, you can see that at different times of the day, because of all of the different things that you plug in and run at different times of the day, you could keep track of when is the power of your house rated in its biggest value and when is it low. Okay, so hopefully this explains a little bit how your house works. I am going to give you an assignment that I want you to go find your breaker box, and I want you to tell me where it is, and I want you to send me a picture of it so you can prove to me that you actually did find it. So instead of having to write what's the most important thing, although I may still ask you that, you're going to need to go find this thing so you can prove to me you know where it is. So hope it's made sense, and we'll see you next time.